students, I welcome you all on my YouTube channel. In this lecture series, we will be doing matrices. So firstly, before we start, I'm gonna discuss syllabus with you. Matrices, okay? So see here, in matrices, we have divided section. We have divided this whole syllabus into four units. In first unit, we will be discussing types of matrices, okay? Rank, variance of rank under element operations, transformations, normal form, and linear, okay, solution of linear equation. This all we are going to do in the first, okay, rank, normal form, and linear equation. In unit 2 we will be discussing diagonal form, reduction to the diagonal form, the order 3, computation of matrix inverse, rank of matrix again is common. Then we will be discussing a solution of system of linear equations using matrix. Okay, so in first unit you can find out the solution, but in second case will be have to find. Third unit we will be doing vector space, vector vector space, linear independence, dependence of dependence, standard basis, and some examples of vector space, spaces, subspaces, right? Sort of things will be done in the unit 3. Then comes the last unit. In this we will be doing translation, dilation, rotation, reflection, okay, um, some basic geometric transformation, and eigenvalue and eigen vectors such transform. So this is the syllabus you are going to discuss in this lecture series, okay? So now so wasting any time, I think so we are going to start with the section. As I told you, in this section we will be mainly dealing with basics of matrices, like definition, types, okay, rank, solution, linear, okay. So this topic will be done in section. So we are quite familiar with this as classes. So we know the definition. What is matrix? We know when mn number is arranged in the form of the ordered m rows and n columns, we call this m by n matrix, right? You are having mn numbers, you arrange these mn number into m rows and n columns, and thus, right? So this matrix is said to be having order m by n, where m represents the rows and n represents the, right? Also, the general element of this matrix is denoted by Aij. Okay. Here also this signifies the which row this element is placed. This, for example, if I take matrix of 4 by 3, 4 by 3, it means this matrix is having 4 rows, right? And column 1, 2, this is the 4 by 3, 1, okay, 3 column 1, 2, 3, 4, 5, 7, 9, minus 1, 0, 2, 1. So see here how many rows you are having? 4 rows, right? I'm just revising the content which you have already done in the elementary classes. I'm not going into the detail, right? I'm just giving you a brush up, right? So you are having 4 row here and 3 column. If you want to name this element 5, so this is present in second and second. This element is a. This is how any element, right? Now let us discuss types of this. Okay, types of. Firstly, pro matrix. Okay, pro matrix. You will be having only, for example, so you see no comma should be here. See here you are having only one row. Column you are having. This is known as pro matrix. Second, column matrix. Column matrix you are having just one column, many rows. This is your column matrix. You are having 3 rows. Then you look at the square matrix. Before square matrix, you write rectangular matrix. Rectangular. Rectangular matrix is of rectangle, right? Simultaneously, I'm going. Square matrix is a matrix in which number of column is equal to number. This matrix is minus 1. So order is by 2. Number of column is equal to number of row. We will be calling it because it is resembling with the in square have all. And rectangular matrices are those matrices in which number of column is not equal to number of column, right? As we did earlier, 4 by 3 matrix. and you were having there four rows and columns, right? But these two are not equal. Therefore, this matrix. Now, mm, another type of matrix is diagonal matrix. Okay, diagonal. Diagonal matrix is such matrix, and which is firstly it should be square matrix. Diagonal matrix is a square matrix which all the elements except diagonal are all the elements except diagonal 0, right? For example, we are having a square 3 by 3 order. So we can have 9 entry here. Diagonal uh, entries, these three entries in this square matrix are known as all the elements except diagonal elements are right in the diagonal matrix. So see here, this must be 0, this must be, this must, this, and here you can have something non-zero, 1, okay, 5, 7, right? So this is diagonal matrix. So matrix will be looking like this: 1 0 0 0 5 0 0 0. This is now scalar matrix. Scalar scalar matrix is a diagonal matrix, and diagonal matrix was a square matrix. Okay, uh, if you take rectangular matrix, it couldn't be diagonal matrix, right? So if you are defining diagonal matrix, it is firstly it is a square matrix where number of column must be equal to number of rows. That matrix on diagonal end. Otherwise, it would be quite pretty. It is not possible to identify the rectangular. Scalar matrix. In scalar matrix, all the diagonal. It is diagonal matrix. Diagonal matrix is called scalar matrix. Matrix if all the diagonal elements, all the diagonal elements are, for example, 2 0 0 0 2 0 0 0 2. This is because all the three elements diagonal elements are equal. Or if you have 12 and this is also 6 because all the diagonal entries are equal and rest of the are all the diagonal entries are equal and rest of the entries are the unit matrix. Unit matrix, it is also diagonal matrix in which all the diagonal entries are equal to which all the diagonal equal to this is not unit matrix, and zero matrix in which six which all the elements are. So this was some okay, one more type of matrix is triangular matrix. Triangular matrix are those matrices which every element above or below the diagonal is definition. You triangular every element above or below is below the diagonal is on the basis of the basis of above and below. This matrix can be called upper triangular matrix or below triangular. See, this is a matrix, right? 1 5, this is your diagonal. 0 4 0 0. Okay, this diagonal. Okay, so see here, all the elements below the diagonal is 0. Okay, all the elements below the diagonal are 0, right? So therefore this matrix is known as, and triangle where triangle is becoming of triangle of non-zero numbers is lying above these zeros, right? So therefore this is known as upper triangular upper triangular. Okay, we will be writing it UTM. Okay, and similarly if I write these numbers in this way, 1 3 9 2 5 0 0. Now this is the diagonal and all the elements above the diagonal are 0, and triangle is becoming here of non-zero number. Okay, this matrix lower triangular, okay, shortly, okay. Four types of matrices: idempotent nilpotent, involute, involutory tricks. Okay, so idempotent means it is idem. Oh, and one way you can say same identity. Okay, right? An idempotent matrix A is called idempotent matrix if A square is equal to A again. Okay, got it? If A square is equal to A again, then this matrix is because we are getting A again, and nilpotent matrix A is called nilpotent matrix if after some multiplication, okay, if we multiply A and A again with itself, after some time, some number of multiplication, we get 0. This 0 matrix. Then this A matrix is different, okay, and this is known as X of involutory matrices, in which A square is equal to this sort of matrix nilpotent. I'm gonna give you example of I see if A is equal to 2, 4, minus 1, 3, 4, 1, minus 2, minus 3. If you scale this matrix, if you multiply it by itself, you will get A again. Just check this out. Okay. So on squaring, you will be getting A again. Listen to, if A is equal to this, then A square, what would be A square? A square would be A into A. One more time, you are going to write it. 1, 3, 4, and if you multiply 3, 2, 4. Okay, minus 4, this would be plus 2, and this would be minus. Okay, total will be equal to 2, right? 4, 2, total is Secondly, you multiply first row and second column, would be minus 4 minus 6 plus plus. So this is equal to 2 and this is equal to minus 2. Obviously it is repeating, or it is the same as a. Therefore we can say a square is equal to, thus this matrix is idempotent. Similarly, there are many examples of nilpotent matrix. Like, I'm gonna give you a problem for you. So that the matrix, I will check this question. So that the matrix A equal to 1 1 3 5 2 6 minus 2 3 is nil potent matrix. Also find out x of L P. As I told you, then there was involutory matrix in this. A square is equal to I. Okay. Involutory example of involutory is uh, here one example of involutory matrix could be this matrix: 1 0 0 0 1 0, A B whatever, this 1 2 whatever. If you multiply this matrix with itself, multiply this matrix with itself, okay, this is your A. Now A square is equal to 1 0 0 0 1 0 A B minus, okay, 1 0 0 0 1 0 A B 1. On multiplication it is 1 10 0 10 0. Okay, in this way you will be getting, after multiplication, 0 1 0 0 0, which is identity matrix. Therefore A square is equal to, this matrix is example of involutory, right? I think this is it for today. Rest of the things, if you have any question, please ask me in the comment section below, or you can ask me in